Good day everyone! For this lecture, we will be studying the post-lab discussion of lipids and lipoproteins. For introduction, what are lipids and lipoproteins? Lipids are commonly referred to as fats. They are ubiquitous constituents of all living cells and play several roles. First, because they are composed of mostly carbon-hydrogen or CH bonds, they are a rich source of energy and an efficient way for the body to store excess calories. Because of their unique physical properties, lipids are also an integral part of cell membranes and therefore also play an important structural role in cells. Lipids are also precursors for the steroid hormones, prostaglandins, leukotrienes, and lipoxins. Next are lipoproteins. The prototypical structure of a lipoprotein particle is shown in this picture, wherein lipoproteins are typically spherical in shape and range in size from as small as 10 nanometers to more than 1 micrometer. As the name implies, lipoproteins are composed of both lipids and proteins called apolipoproteins, and the main role of lipoproteins is the delivery of fuel to peripheral cells. The various lipoprotein particles were originally separated by what we call as ultracentrifugation into different density fractions, which still form the basis for the most commonly used lipoprotein classification system. In Table 10.1, we can see that the classification of the lipoproteins chylomicrons, VLDL, LDL, and HDL were arranged according to increasing density. For lipid and lipoprotein analysis, we will have lipid, cholesterol, triglyceride measurements, lipoprotein methods including HDL and LDL, apolipoprotein methods, phospholipid and fatty acid measurements. For lipid measurement, lipids and lipoproteins are important indicators of coronary heart disease risk or CHD risk. CHD is often caused by cholesterol, which is a waxy substance that builds up inside the lining of the coronary arteries, forming plaque as seen in the image. Next is cholesterol measurements. Serum or plasma specimens collected in blood collection tubes from patients who have fasted for at least 12 hours are usually preferred for total cholesterol testing. If analysis is delayed, the serum or plasma specimen can be refrigerated at 4 degrees Celsius for several days. The reference method is a gas chromatography mass spectrometry or GCMS method that specifically measures cholesterol and does not detect related sterols. This method shows good agreement with the gold standard or the so-called definitive method called the isotope dilution mass spectrometry or IDMS. Although several enzymatic reaction sequences have been described, one sequence shown in figure 10.4 is the most common for measuring cholesterol. The enzyme called cholesterol esterase, also known as cholesterol ester hydrolase, cleaves the fatty acid residue from cholesterol esters, converting them to unsterified or free cholesterol. The free cholesterol is reacted by the second enzyme called cholesterol oxidase, producing hydrogen peroxide or H2O2, a substrate for a common enzymatic color reaction using horseradish peroxidase to couple two colorless chemicals into a colored compound. The intensity of the resulting color is proportional to the amount of cholesterol and can be measured by a spectrophotometer, usually at a wavelength of around 500 nanometers. Next, we have triglyceride measurement. Measurement of serum triglycerides in conjunction with cholesterol is useful in detecting certain genetic and other types of metabolic disorders. The triglyceride value is also commonly used in the estimation of LDL by the Friedewald equation, wherein LDL is equals to cholesterol minus HDL minus triglycerides over 5 when we are using milligrams over deciliters as units. Several enzymatic reaction sequences are available for triglyceride measurement, all including lipases or the bacterial lipase to cleave the fatty acid from the glycerol backbone. The freed glycerol participates in any one of several enzymatic sequences. A second sequence involves glycerol kinase or the glycerokinase and glycerophosphate oxidase, coupled to the same peroxidase color reaction described for cholesterol. This is the end of part 1.